Hello, welcome again to this YouTube channel. Okay, now that you know already the idea behind having a first principle of differentiation, okay, now our question is okay, how can we find our f prime? Okay, f prime in this case is your first differentiation. Okay, I'll give you two example. The first one is quite straightforward example and followed by not that straightforward example. Okay, so let's us try to solve this one first. Okay. Okay. Now our main intention is to find our f prime. All right. So we make full use of our concept. I'll give the definition for my first principle of differentiation, okay, so that you can just play along using this particular formulation. All right, so do not forget this. Okay, this is my okay, I put them together like this. It's a little bit messy, but I think you get the point. All right, so this is my main uh, uh, main definition. Okay, my main definition for my differentiation first principle. All right, so if you look at this one, if you want to find f prime, you need to know your fx plus h. You already know your fx and you already have the constant value, which is h. Okay, so in this case we still didn't have fx plus h. So I will create my fx plus h. I'm just using the x plus h inside my original function. Okay, so I do it very, very carefully and slowly, one by one, so that you can see the values, why that is so, and whether we can make sense out of it. All right, so you have this one already. Once you have this, now you can start working out your um, working formulation. Okay, so you make full use of your definition. Okay, but now in this case you already have your fx plus h, which is I put that in bracket so that I don't get confused. This is my fx plus h, and then I only put my original fx, and then I still put my h over here. Okay, but do not forget that your limit now, your h must goes to 0. Okay, so okay, I put the segment over here, so it does not disturb the previous the next example. And then so once you have this, okay, you can just simplify this value. So you have, okay, you know this one is just a simple algebra formulation. Sorry, simple algebra solutions. 3x minus 3s just equals to 0. You are left with 3h. And then your 4 also minus 4 equals to 0. Okay, so you only have this. And then you know when you are using the algebraic forms in your limit, okay, once you have this numerator and denominator, you can just simplify this into 3. And then you also know if you have a constant value, and then whatever h that you have, okay, doesn't matter, your value is just 3. Okay, and then this is actually the solution for your f prime. This is your 3. Okay, so basically you will have f prime x equals to 3. Voila, the first solution solved. Okay, now we move on to the next, not that straightforward solution. Okay, in this case, if let's say I want to find my um, f prime x, okay, my question is to finding f prime x. So how to do just that? First, I do the same thing, but now we are dealing with a surd. As you know, surd is not that straightforward. Okay, so once you have this, okay, you just put your formulation in place. Okay, you will now have x plus h, that is your fx plus h, and then you minus with your original fx, and then you are dealing with the denominator h, and then you know your h must go to 0. Okay, how to solve this actually? If you solve an algebraic formulation, you put 0 into h, that does not make sense, right? Because your denominator now will become 0 and you cannot solve anything. All right, so basically you know that, oh, cert, what are the properties that you can utilize to make sure that suddenly you are not dealing with cert anymore. What I have in mind is the conjugate. Okay, alternate the alternate sign of my this one, the alternate sign of my third, like this one, so that you can see over here how I'm going to manipulate this idea. But as you know, once you put the values on your on your nominator, of course you need to also introduce the same value on your denominator, because you know this form of denominator divided by the same form of denominator is just equal 1, so it does not change the behavior of your original function. So that will be fine. And then later what you should do now, okay, you do the same thing like this one. Okay, you expand them together. Okay, once you expand them, actually what you have is just x plus h. Okay, remember your formulation. All right, and then you are sorry, and then you are like this. Okay, and then you are left with just x, because once you expand, you finally actually live with third x plus h square, and then the other one is third x square, and then third you have a square, so it's just like half times 2, so it's just 1. That's why I only put this one. And then you notice, oh, it does not make things simpler, right? Because your denominator now is a little bit more complicated. Okay, but that's okay. We just do it slowly and see whether there are some things that is getting better. Okay, do not get panic in the middle of your calculation. All right. So basically, you look back at the your nominator. Now your nominator only left with h, right? Because your x minus s is just equals to 0, and then nothing happened to your denominator, but you can see what happened now is, oh, I have h in my nominator and I also have another h in my denominator. Then what should we do? We cancel them out. All right, so I put over here. And then once we cancel that out, okay, this one is for the one at the bottom, right? Not equal to the one at the top. Okay, what happened now is, okay, once I have this, my limit now only becomes 1 over third x plus h, okay, plus third x, okay, and then my h now become goes to 0. Okay, in this case, I think now you can see, if you put the algebraic formulation in action, okay, using the solving the limit that you have, you don't have any problem at all, right? Because even if your denominator has h inside there, but if you put 0 inside your denominator now is not getting 0. So you are safe. All right. So you are safe. So using that idea, I'm just substitute my h goes to 0 using algebraic formulation. And then this is what I have. Okay. My h now equals to 0. I only have with x plus third x. All right, and then this one is just the same as writing this. And then I know this is my original intention or objective, f prime x. Okay, so voila, we get the first one. and also we get the second one. All right. So normally, even though the calculation is a little bit tedious, but if you do it slowly and carefully, especially if you understand the concept of having to use x plus h and why you need to put limit h goes to zero. Okay, if you're still having a problem with that particular motivation, you can always go back to the previous video on how to make sense or how to formulate your first principle of differentiation. All right, so I hope you understand the lesson today. So I'll see you guys on the next lesson. All the best.